When meeting start or it's
Yeah, Sensei, a few minutes
a few
we
minutes.
will start. Yeah, for the meeting.
Yeah.
Robi minta oke dah.
Oh, not testing, still testing and almost testing is almost finished.
Yes, testing finish, Sensei.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, and welcome to today's webinar with the topic Coastal Acoustic Tomography for the Welfare of Coastal Communities. It is my pleasure to be master of ceremony for today's event. I'm Zilda Dona, staff of Center for Regional Resources Development of Technology, BPPT. And we would like to extend our warm welcome to our Deputy Chair, Bapak Yudi Anantasena, our Director, Dr. Agustan, Chair of IEEE OESTEMS, Dr. Marina, and our distinguished speakers, and also to all participants for today's agenda. We appreciate you taking time of your busy schedules to join us today. And today's webinar is to celebrate the UN World Ocean Day that held on 8 June 2021. This webinar is conducted with the collaboration of IEEE Indonesia Section Oceanic Engineering and Technology and Engineering Management Joint Societies Chapter, Center for Regional Resources Development of Technology, and also the Indonesia Remote Sensing Society. But before Dr. Reni Sulistiowati start discussion as our moderator today, we pleased to welcome our Deputy Chair for Natural Resources Development of Technology, Insinyur Yudi Anantasena, to deliver his welcoming remarks. Please welcome Mr. Yudi Anantasena. Time is yours, sir.
Thank you, Zilda. Thank you very much. Good afternoon, everybody. Welcome to this webinar. I hope everybody in the good health today. Then we can join this webinar. Then can fruitful for all of you. On behalf of VPT, I welcome you all to this webinar series that jointly
Saya masih belum bikin narasinya nih.
Organized by PTPSW. PTPSW is a regional natural regional. I forgot the
Natural Resources Development.
Natural Resources Development Center of Technology for Natural Resources Development, Pak Bu Marina. Jointly with IEEE Oceanic Engineering Society and Technology Management Society, and also MAPIN, National Remote Sensing Society. This webinar will discuss the use of coastal acoustic tomography, or CAT, for regional resources development. Our appreciation and gratitude especially go to Kaneko Sensei, who will give a special lecture to us and share his experience regarding the utilization of CAT for marine resources inventory, for example, fisheries sector. BPPT, as an extraordinary institution, always looking forward a frontier technology that can be applied to improve our prosperities and welfare through technology and innovation. This event is one of a webinar series that celebrate the UN Ocean Day and also commemorate the start of decade of ocean science, where through science that focus research goal of clean ocean, healthy and resilient ocean, predicted ocean, safe ocean, sustainable productive ocean, transparent and accessible ocean, one of the results will be the welfare of the coastal communities. We at BPD have utilized tomography technology since 2015 for various applications. One of them is for Indonesia Tsunami Early Warning System, or we call INA TEWS, which will be presented by the following keynote speaker. Finally, I congratulate the speakers and participation and wish for a fruitful meeting today. And we can not only can meet here, that we will do the work forward between among our institution or scientists. Thank you very much. Very good afternoon.
Thank you very much, Bapak Yudi Anantasena, for a warm welcoming remarks and also reminding us for the collaboration we have in the future. So to formally start the webinar, may we call on the chair of IEEE Indonesia section Oceanic Engineering and Technology and Engineering Management Joint Societies chapter, Dr. Marina Frederick, for the opening remarks. Please welcome Dr. Marina. Time is yours, please.
Thank you, Zilda. Good afternoon, everyone. First of all, I would like to say to my Honorable Deputy Chair, Bapak Yudi Anantasena, and to Honorable Director PT PSW, Dr. Agustan, and to Honorable speakers for today, distinguished speakers, Sensei Kaneko, Harun Idam Akbar, Dr. Dani, and Dr. Fadli. Welcome to the webinar today. Please let me share a little presentation. Okay, let me see. Okay. Oh, okay. All right. So today, the webinar today is part of a series of webinar that commemorates the World Ocean Day, which took place on the 8th of June. And today, specifically, we will talk and learn about coastal acoustic tomography for various applications. In here, the picture on the left is showing the local community that are very interested in looking at the installment of the tomography instrument that will be deployed. So it is our wish that through this collaboration with the local communities, they are understand and they are committed to also understand the resilience and also the potential of tsunami in that area and to be prepared. Okay, let me see. Okay, right. So here is the map of Indonesia, and we can see that Indonesia is comprised of a total area of about 7.8 million kilometers square, and about 70% are water. So it is important for us that we understand and we protect our water, our surrounding waters. Okay. For our joint chapter, it is developed or published by early this year in February. It is part of the Indonesia section, and it is called Indonesia Oceanic Engineering and Technology and Engineering Management Joint Chapter. So it's a joint. Somebody's calling. Okay. Okay, let me take it off first. All right, I'm very sorry about that. So our joint chapter are a collaboration between two societies. It is called Oceanic Engineering and Technology and Engineering Management Society. So our joint chapter supports the UN SDGs number 14, which is life below water, which is to conserve and utilize marine resources for sustainable development. And also our joint chapter also promote and support the UN Decade of Ocean Science for Sustainable Development. How is this chapter supporting that? It is through conference, webinar such as this one, publication, technical training, and networking. At the bottom is showing our website, and we welcome you to visit it. But I would like to inform you that it will be live in a few days. So right now it's not yet on. Okay. All right, so I would like to introduce our activities. Today is the third activities of this joint chapter. The first one we did in the 2nd of June, which is focused on mangrove and coastal region. And just yesterday, we conduct a webinar on cable-based tsunamimeter as part of the Indonesia tsunami early warning system. So today we will learn about coastal acoustic tomography for the welfare of coastal communities. And in next month, the 15th of July, there will be a technical demo on identification of mangrove. This year, this day is to commemorate the World Youth Day. And there will be 2 international conferences. The first one is going to be on the 28th September. It is called International Conference on Technology and Engineering Management and Innovation. The best practice on technology engineering and management toward better productivity. We will accept papers, and the submission deadline will be in July 5th. Towards the end of the year, we will have the 2nd international conference. It will be on the 8th and 9th November. It's the Ocean Engineering Technology and Innovation Conference, Ocean Observation Technology and Innovation in Support of Ocean Decade of Science. And we also accept papers, scientific papers, and the deadline is the 27th of September. So today, just as I mentioned before, we are celebrating the World Ocean Day and the start of the Decade of Ocean of Science for Sustainable Development. In here, the scientific efforts of the Decade of Ocean Science are clean ocean, healthy and resilient ocean, predicted ocean, safe ocean, sustainable productive ocean, and transparent and accessible ocean. All of these, one of them are for the well-being of the coastal communities. So we are, the joint chapter do support researchers in ocean engineering and ocean science. And for that, I wish you happy World Ocean Day. Thank you very much.
Thank you, Dr. Marina. Such wonderful remarks for today's webinar. And after this, we move to the next agenda. And right now, I would like to invite Dr. Reni Sulistiawati as our moderator today to lead this webinar discussion. And the floor is yours, Dr. Reni.
Thank you, Silda. So, good afternoon, ladies and gentlemen. Your Excellency, the Deputy Chairman of TPSA, Bapak Yudi Anantasena, and then the Honorable Director of PTPSW, BPPT Dr. Agustan, also to all the speaker and participants who joined today. So before we start, I'd like to welcoming all of you today and very happy to meet you. My name is Reni Sulistiawati and I will be moderator for today's webinar. So this afternoon, We will hear the presentation from 4 speakers. The first one is from Professor Dr. Arata Kaneko from Hiroshima University. And then the second one is from Dr. Fadli Samsudin from the Marine and Fishery Division in West Sulawesi. And then the third one, the presentation from Dr. Dani Arifianto from Institute Technology 10 November, Surabaya. And then the last one, the presentation from Mr. Harun Akbar from our center. So the presentation today related with the coastal acoustic tomography for the welfare of coastal communities. Each speaker will present the material about 20 minutes. And for all the participants, you can write down your question or comment in the chat room. And you can write in Bahasa or in English. Either way is okay. And we will have discussion after 2 speakers. So 2 speakers first and then discussion, and then another 2 speakers and discussion. So without delaying any longer, now we are pleased to welcome Professor Dr. Arata Kaneko from Hiroshima University. I would like to read a little about his. So he is the senior physical oceanographer and well known for the development of the coastal acoustic tomography system even in the world. He will be sharing with us the development of CAT system, coastal acoustic tomography system for fishing ground and aquaculture. So Professor Dr. Arata Kaneko, time is yours.
Thank you very much, Dr. Reni-san. And I would deeply appreciate Deputy Chairman Park Yuji Anatasenan-san. Okay. I am very appreciated. If I have a good chance of introducing the chat study today. Okay. And should I start my presentation now or?
Yes, please, Sensei.
Oh, okay. I should say some brief introduction. In the last 20 years, it was my great pleasure to work with the BPPT friends led by Dr. Fadli Samsudin and Dr. Reni other person. Especially, noticeable results have already been obtained in the Bali and Lombok Straits. So I am retired and my remaining life is not so long, but my final mission in the remaining life is persistent support of the CAT study in the Indonesian Sea with a fruitful application field of CAT. Indonesian Sea is the most important field of CAT study. So many straits, bay, inland sea, or through flow, passing the strait, or and so many dynamic phenomena, interesting dynamic phenomena, or so many application fields, so many. But Dr. Fadli is 20 years ago, or he have a strong interest in the acoustic tomography, and he beat to the Hiroshima University. So about 20 years ago from the USA, I surprised why he has such a long-term plan acoustic tomography.
So Sensei, Professor Kaneko, I'm sorry, could you share your presentation material share screen?
Oh, using the presentation material?
Yes.
You can see?
Yes, Sensei.
Yeah, using the presentation material, it's a very good idea. Sorry. So I should follow the presentation material. So coastal acoustic tomography is a innovative technology for coastal environment monitoring and management, which has a four components. First is a monitoring of Indonesian through flow, ITF. Second is a 3D mapping of temperature and velocity field in world coastal sea, not only local one. Every world sea needs a chat system. These are most important points. The reason why I still work with a chat is this. It's so important in the world oceanographic community. Okay? So I have to cannot stop the chat study. so I ask the next generation Dr. Fadli-san, Indonesia, or you chat team in Indonesia, and Chinese chat group is 1, 2, 3 or 4 group, and Korea group is started in Inha University and Korea Ocean Korea Institute of Ocean Science and Technology. So that chat study is quickly developing in the East Asia or Southeast Asia, only Indonesia in Southeast Asia. So, and the third component is monitoring of temperature field in fishing ground and maritime aquaculture farm. Fishing ground is this host component is tsunami early warning at the inlet of bays and straits. It's ongoing. Jenny-san is a lead the inner chat program in my memory, I see. So now I focus fisheries topics. Third component. Third component have mainly 4 topics. Global ocean warming. I don't know how global ocean warming developed in the Indonesian Sea, but in Japan, global warming grew up quickly around the sea, around Japan, and to sea around Japan, about 2 degrees temperature increase, very big. So heavy rain and heavy snow and river flood disasters every year it's occur in Japan. How is the Indonesian sea? But maybe not so much. Northern hemisphere global ocean warming is quickly developing. Second one is internal solitary wave. This big wave is generated about Shield is a shallow bank near the southern inlet of Lombok Strait, propagates northward in the strait and attack the aquaculture farm. I know the 1 or 2 aquaculture farm west of Lombok Island. Sometimes it's a fishes in the aquaculture farm suddenly die. Fazli-san said. And vertical mixing in fishing plant is also important. It's, the nutrient water exists in the near bottom, and its vertical effect vertical mixing mixing, bottom water is rising, and surface water can get a nutrient salt. And fourth one is inversion of cold water. Coastal upwellings generated along the south coast of Java and Lombok Island intrude into Lombok and Bali Strait and cool the water in the strait. And coastal upwelling transfer the nutrient water into the strait. This is nice for biological resources. Nutrient water is supplied from the coastal upwelling. It's occur dry season. Monsoon coming from the Oceania continent. Okay, so considering these topics, how cat is so important to measure this. But cat measurement have to find the good platform near the coast. It's not so easy. Sometimes I compare cat platform with the lighthouse. Lighthouse is well managed by government, but no government manage the cat platform, even in Japan. We need if we need a lighthouse, we also need a acoustic house, cat platform with a cat platform. So important, but it cannot be realized until now. So second page is shows some cat system, cat field system at upper left hand. So and subsurface type cat MCAT system. MCAT is a newly developed cat, and mirror type is called mirror type cat. Its system is stored in the glass spheres. Okay? Also, many battery cell and electric board it's stored inside the glass board. So land type cat system is at lower left. Okay. This is tsunami Indonesian tsunami project operate this type of system using the surface buoy. And at the lower right, it's cat system deployed in the aquaculture farm is sketched here, and at the corner of aquaculture farm, cat system is located and send the sound. Reciprocal sound transmission is performed between a pair of stations, and temperature structure in the aquaculture farm is can be monitored by this CAT system. Temperature structure in the aquaculture farm is very important to manage the aquaculture fish. So I prepare the 2 page, but it's just finished or that's all I want to present today. Or thank you very much for your concern.
Okay, thank you very much, Sensei.
Thank you.
Very good presentation and also a very interesting topic. So it will be important for the fisheries and marine in our country as well, that we can use the acoustic tomography to for aquaculture or fishing ground. So for all the participants, please be patient. We will have the discussion after the next presentation.
Thank you.
Thank you very much, Sensei.
Yeah.
So now we are continuing for the second speaker. We are pleased to welcome Dr. Fadli Samsudin. He is also one of the experts for the coastal acoustic tomography technology and now working at the Marine and Fisheries Affairs in West Sulawesi Province. Dr. Fadli will share to us about the application of coastal acoustic tomography for stock assessment. Dr. Fadli, time is yours.
Thank you so much, moderator Dr. Reni Sulistiawati, yang terhormat Pak Deputi, Pak Direktur, sobat saya Pak Agustan, yang mengikuti Zoom ini, rekan-rekan senior dan pemerhati akustik di seluruh Indonesia. Saya lihat ada 110 ya yang hadir saat ini. Bu Marina yang mengarrange, thank you so much. So Dr. Kanekon Sese, very nice to introduce my talk actually. I just will show you. It is already shown on the screen.
Yes, Pak. And
okay.
Could you slideshow?
Yeah. Wait. So some utilizations of how this coastal acoustic tomography for the fish stock assessment, this due to our task in the Marine and Fisheries Affairs in the West Sulawesi Province. Normally, we will focus on the Bala-Balakang Island. This is still an idea because we just tried to do this experiment this year. And we will look at the capability of this technology, the new frontier technology, I think. As Sensei, Kaneko Sensei mentioned, this innovative technology and the current measurement and also wave. So if you look at on this Makassar Strait, actually, this is the bathymetry. You can just see that this is a deep, mostly Makassar Strait has 30 or 350 kilometer width, but in the eastern side that passing to the West Sulawesi province, mostly deep. They have a seals, yeah, around here is about 1700s, and going to the north, come directly to the 2700s, 1000 difference. So this is very interesting actually. So I will give some introduction why the coastal acoustic tomography used in this activity and some idea to do stock assessment in the Bala-Balakang Island. So one the emerging actually task in our office actually, if you look at on this graph, yeah. So the productions of captured fish in our province actually since the last 2020 reducing and then become the lowest in the Sulawesi Islands from the 6th province. So it's about like every year's average 65,000. This is quite small compared to the South Sulawesi. The biggest one can reach about 300,000 tonnage. It's very much different. Even is still in the same strait, Makassar. And if you look at on the our potentials fish, especially for the deep sea, yeah, we know that this is very rich actually, but we still doesn't explore much actually. And if you look at from the data from the KKP, Reni, this is only 15 or 20 minutes presentation, yeah?
Yes, Pak.
Okay, yeah, I just
Okay.
going quickly. So our management, we call it the fishing catch area is 713. If you look at on this is still some numbers for the investment can be like going to the 4 billions, yeah, trillions actually, 4 trillion rupiah is actually still big chance for the to exploit in terms of the infestation. And normally to understand the fish stock assessment for this area, we use this kind of like a method using the biomass, and then we calculate. So normally this biomass use the satellite, yeah, from the sea surface anomaly, chlorophyll, sea surface temperature, and we derive some numbers to get the fish stock in some regions. And I try on my student on in the master program University of Indonesia. I try to, because satellite only just limited only the surface, and we did like how using some direct measurement with the temperature and salinity to understand for the 3D, kind of like a 3D thematic map for the tuna catch in this case is in the southern Java waters. As look at on this, it's very interesting. Some tuna actually very much spatially has some difference. Yeah, tuna a bit diverse compared to the yellowfin in the in the surface. And following this kind of satellite, we consider that they have some limitation. So we in BPPT at the time is considering to use this kind of like a coastal acoustic tomography. Why? Because I just show you 3 publications related to our works. Actually, since 2016, yeah, we start to use this to use and assess the application of this technology, the new technology, in Bali and Lombok Strait, and some publication already. So mostly in the Bali and Lombok, we can use this technology to detect some physical phenomena like internally solitary wave. We call it solitons. This internally solitary wave is mostly the same like a tsunami. This is why recently during the last 3 years we developed this coastal acoustic tomography for the early warning system. A tsunami early warning system uses the same technology, and they are very much progress in terms of the technology. And also we are heavy. There are a strong group of people in engineers and scientists get together in BPPT to develop this until now. There are much progress actually. And I now try, because I stay now in the West Sulawesi, try to put this technology in the Bala-Balakang Island. I will show you later the reason. So because of this idea that this is proven already, the technology with the publication and the Q1 journal. So we believe that this technology can be used on this. So fish stock, this is our plan this year to put this experiment. So why in Bala-Balakang Island? This Bala-Balakang Island actually very nice. They are located in in the Makassar Strait belong to our West Sulawesi province, and about 60 mil going to the west from Mamuju, our province mother city. And if you look at why this is very interesting for us, because this is the second actually longest after the Great Barrier Reef in Australia. If you look at this, and yeah, this is in the Australia. It's actually the longest one, about 2,000. But the second one, the longest Great Barrier Reef, is actually in this Balabalaka Island, about 650 kilometers long. So you can imagine with the reef, yeah, of course there are many demersal fish and what a very prospect with the fish productivity there. So this is the Great Sunda Barrier Reef here, yeah. You look at this along the Wallacea lines, and this is actually a bit far, but close to the East Kalimantan rather than but this is belong to the West Province. So we actually, this is just showing you quite quickly the idea of why we use tomography to use a fish stock assessment. This is actually still in the experiment, but we believe we can use this. Why? Because this is the idea actually. We will use the same technology before with the same frequency, whatever, but we used to put in along the coastal lines. And the fish actually we can detect using the back scattering or something like that. So you can see later about these theoreticals. But anyway, yeah, these two can be detected. They have some theoreticals that we can derive and some tables like this. I just quite quickly skip this, yeah. And so for some numbers, we will understand how the diameter very much relate with the frequency using this diagram. So say like 30 diameters of this transducer we use and related to maybe transducer about have a strength to detect the piece about maybe around 32 decibel. But anyway, you can look at on this kind of table. And we did already some experiment using this is during we apply the Ristek Pro mostly every years from the Ristek Dicti at the time. Since 2016, actually, we intensively every year come to visit Kaneko Sensei in Hiroshima University and doing many kind of experiment. One of these is actually a fish. For the long-term goal, actually, a fish stock.
Hello, Pak Fadli.
Father-san voice is free.
Yes, Professor Kaneko, I think there is some internet problem. Hello, Pak Fadli. Okay, then. Okay, I think there is some internet problem with Dr. Fadli Samsudin. So while we are waiting for Dr. Fadli to connect again, I would like to inform you that you can ask or you can give a question or comment through the link which already distributed by Mbak Zilda in the chat room, and you can ask by Bahasa or English, but please not in Japanese or Chinese because I couldn't read it later. So you can ask in Bahasa or in English. And we will
日本語でもだ構いませんけど。
So, okay. K-pop Fadil not yet coming again. So, okay. Maybe we can step for the small question first while we are waiting. Basilda, is there any question in the question form?
Yes, there are two questions from Pak Imam. The first question is for each of, the first one is to get the optimal result of CAT observation data, what kind of requirements, technical or any related things need to be considered? That's the first one, Bu Reni.
Okay, so maybe you can put in the slideshow, Zilda.
Okay, wait 1 minute. I will share screen first. Okay, can you see it?
Okay. Okay, so maybe we can try to ask the first question. This is for Professor Kaneko. So the first question, Sensei, to get the optimum result of coastal acoustic tomography observation data, what kind of requirement, technical or any related things need to be considered?
Yeah.
Based on your experience.
So optimal data acquisition is so important and difficult point. That's a good question because when we visit the observation site, first we need past or previous temperature or salinity, sound speed, vertical profile of sound speed, which depend on the temperature, salinity, depth. So, and considering the vertical profile of temperature, salinity, and take care at the bottom profile along the sound transmission path. What sound the bottom profile we have to use. This is and distance from the between the two stations. What distance we have to use? These are three most important factors. So, in my case, considering the previous experience or previous knowledge or and every time I ask the vertical profile of sound speed profile, previous data need or before the transmission start, if CTD cast is done and we get the vertical profile of sound speed, and but recently the Google Map or Google Earth is give us the very good information. So horizontal the geographical site map is well obtained. Another, that's okay. Using the recent information data, we can without reaching the observation site, we can many information, geographical information we can get. Another thing is final third parameter is a bottom profile. But not so detailed or roughly we need a bottom profile or depth. And
Okay.
but that's something like that. We need such information. But in the recently, Professor Park Jae-hoon, Korean former PhD student, he came back to Korea from the USA. He was really genius student. He started the cat study now, and he think the he said the
Okay,
same,
moderator.
he said same thing or how to find the optimal condition.
Okay.
So his case is AI, artificial intelligence. He used the AI. He how to he can do something.
Okay. Thank you very much, Sensei. So I think your answer already covered 2 questions from Pak Imam. And the location is different for the preparation, and we need to know the information about speed profile or bottom profile for each location. I think that's for the technical. Okay, so now Pak Fadli already joining again.
Yeah. Sorry, moderators. I don't know why disconnect suddenly. So just a few slides to finish. So we also tried to measure in the Yamanaka Ike pond. Try to see the omnidirection, some like idea how to get fish on the ponds, how much like to calculate how many or something like that. So the experiment done already, and actually,
sorry, Pak, the
sorry?
slide so is not coming.
Oh, really? Wait, share again. So these are coming.
Explorer now.
Not yet?
We saw the Explorer, Pak.
Oh. So anyway, actually, that's almost just my last slide, Dr. Reddy. So maybe we can just discuss. I just saw how this is mostly theoretical, some numbers that I want to skip quickly. So just for conclusion, actually, we designed already some how to we manage for this using tomography setting on the Balabalakang Islands. But anyway, we in DKP, West Sulawesi Province, will soon this year to do experiment in the Balabalaka Island using the coastal acoustic tomography to get to understand like how many fish stock assessment in some area in that we believe the resources are very abundant. I think I just close my talk, and we can try with the discussion. And I will show you later maybe for some up to the question, Dr. Rene.
Okay.
Some important features.
Yes, thank you very much, Pak Fadli. So while we are waiting, actually we already open for the question. And so thank you very much for the presentation. Basilda, is there any question in the form for now?
Not yet.
Okay. Okay, so maybe the participants still already typing. Yeah. So until we're waiting for the question, I think we can continue first for the next speaker. And the next speaker will be Mr. Harun Itham Akbar, STMSE. So he is one of the our younger researcher in our center, and joining with the development of coastal acoustic tomography for many applications in Indonesia. So Mr. Harun, are you ready?
Ready.
The time is yours.
Thank you, Dr. Reni. Bismillahirrahmanirrahim. Good afternoon, ladies and gentlemen. Thank you, Dr. Reni, as moderator for giving me a time to sharing information about our topic. I will share screen. This is our topic, application and development of coastal acoustic tomography system in Indonesia. This is our topic I will describe today. First, I will explain briefly about definition and understanding of coastal acoustic tomography system or CATS. Second, application of CATS and data result from our experiment in PTPSW BPPT. And third, about development of CATS until today. And lastly, fourth is about conclusion with content summary of this material. This is what we know about tomography. Technically, this is already explained from previous presenter. I just repeat it briefly. The coastal acoustic tomography system, we call it CATS in acronym. This is a couple of CATS can measure travel time and reciprocal direction between two acoustic transmission or a pair and reception station, or we call it acoustic station. The mean travel time is converted into the path average sound speed, and the travel time difference is converted to the path average current. The two-dimensional and three-dimensional mapping of currents and sound speed fields are obtained through an appropriate inverse analysis when observation domain is surrounded by a multi-acoustic station. This is from Kaneko Sensei in 2015. How CAT working? This is a picture of working principle of CAT using a pair of station. This is pair. This is station and station of CAT. And the transducer here transmit an acoustic signal to here in the same time. Together in the same time, the acoustic signal from this transducer propagation to and receive in this transducer, vice versa. In PTPSW BPPT, we have several kinds of CATS for specific use. This one is 10 kilohertz CATS. This one 10 kilohertz CATS for using for around 1 until 10 kilometer distance between pair station. The yellow one, this is 5 kilohertz MCATS, or we know as mirror coastal acoustic tomography system. In 2019, this equipment is used in Lombok Strait. The equipment is used for receiving and forwarding acoustic signal or repeater, like a repeater from coastal transducer for coastal transducer. This MCATS placed underwater near the seabed. This is river coastal acoustic tomography system. This is Indonesian original product developed by tomography team in BPPT. This equipment is used for measuring water transport in river and lake using 50 kilohertz frequency. And the last one, this is 4 kilohertz tsunami coastal acoustic tomography. This equipment is currently installed in Lombok Strait as part of Indonesia Tsunami Early Warning System program. And this is how we install the CAT system. This is three type of placement. This one is jetty placement using jetty, and the buoy here is placed so transducer is can be like this, and the floater placement using a swivel for transducer safety, and the buoy placement is using swivel too for transducer safety. This transducer is mounted upright. This is flowchart of data acquisition we use now. The data from the CAT system is transmitted to the database server using telemetry. And in the database server, the data processing will process automatically, and then the data will visualize to the web. This is CAT system, and the data is transferred to database server and processed. This is our survey roadmap from 2014 until now. The survey area was selected. There is so many area we do for survey. The survey area was selected from consideration of various factors that are important for marine knowledge update to be useful for our country development. This is first trial of CATs in Bali Strait survey area in 2014 to 2015. In this map, in the bottom, we can see that two pair station for B4 to B3 and B4 to B2 is placed. In the survey, we successfully reconstruct the temperature. This is temperature from this is from the blue one is from 0 to 20 meter, and the red one is average current. We successfully reconstruct the temperature, and this is the tidal data. This is the red dot data is from observation, and the black one is from the model data, the tidal data. And before we do the observation, we do simulate the ray diagram and temperature diagram like this. In 2016, the second trial of CATs in Bali Strait is using multi-pair data. From this observation, we successfully reconstruct the two-dimensional current from all CATs pair data. We can see here the two-dimensional current reconstruction. Our leader has conveyed the result to the ASDP and Ministry of Transportation for shipping safety in this year. In the same year, we do observation in Penajam Strait for support the Technopark program. We successfully reconstruct the temperature in the area. This is the temperature reconstruction, and this is the coastal acoustic tomography system data, and this is the current speed data from coastal acoustic tomography. And we validate with model data and observation data in here. In 2018, we developed the CAT program for detection the submarine. In this picture, this is the observation area. In this concept is like this: if the submarine is in our observation data, we will catch the data from this submarine. In this picture, we do observation in Indonesian. This is in Indonesian Navy anniversary. In Indonesian Navy anniversary. In this data, we can see that in this data here, we can see the ship movement catch by cats. This is from 6 and 10 o'clock, and this is 6:20 o'clock. The ship is moving. We can see the red circle here, the moving data. And in 2019, we use a mirroring coastal acoustic tomography application to provide internal solitary wave data in Lombok Strait. The data here, this is the observation data, and this data here is reconstruct the temperature data from different depth. The red one, we can see the legend here, and this is the correlation pattern data. From correlation pattern, with first acoustic signal and second acoustic signal is in here. We can see here. So we can observing internal solitary wave. From this data, you can see from the paper by Dr. Fadli Samsudin, and you can see there. In 2020, we modified the program, the CATS program, to see the signal to noise ratio. The concept here is if the sediment in the lake is less, the signal to noise ratio will propagate freely. So the SNR value will increase, and if the sediment is high, the signal cannot propagate smoothly, so the SNR value will drop. This is the concept, and this is the data. This is from our observation. This SNR signal is still high. And this is temperature variation in the survey area. We can see here the temperature. If the rain, the rain is coming. If the rain is coming, the temperature degree is decreased. We can the data the catch the data. And for 2020 until now, we built a CATS application for tsunami monitoring. This is a part of INA TEWS, Indonesian Tsunami Early Warning System program. The concept is if there are disturbance of largest arrival peak repeatedly in here, it can be sign for tsunami warning. This is the data from tsunami CAT, and we do plot the data, and you can see in the tomography bppt.go.id, and we try to process the data using, this is the blue one. The blue one is the ticket data, and the red one is tidal data. And we can analyze using other marine data, and this is still developed until today. Now we will talk about development of CATS in PTPSW BPPT. This is the Reset Pro program for 2015 until 2019. In 2015, we study about operate the coastal acoustic tomography and learn more about data processing flowchart. And in 2016, we study about develop MCAT and try to develop FishCat and RiverCat. And in 2019, we study about develop tsunami coastal acoustic tomography and develop river acoustic tomography development combined with remote sensing data to monitoring the Jakarta flood using water level combined with water transport data using RiverCat, AirCat. This is our originally product RiverCat that introduced from 2017, and this is the product. And in 2019, we try to develop to monitoring the Jakarta flood monitoring with this cam. And for 2020 until now, we still develop the support system for tsunami coastal acoustic tomography data. This is developed for telemetry, and we do migration the data from MATLAB to AirData, and we still develop the website tomography.bpt.go.id. The conclusion is, first, almost all marine physical parameter can be processed using CATS data. The second, CATS application for submarine detection is possible with further development. The third, CATS data can be used for other water purpose, such as lake monitoring and flood monitoring. Fourth, there is some modification of CATS hardware and frequency for specific application. Fifth, the CATS has successfully acquired data and continues to be developed. And sixth, the CATS development in Indonesia took time and still continues. That's all my presentation. Thank you for your attention.
Okay, thank you very much, Mr. Harun. Very nice presentation. And yeah, based on your presentation, we can learn that actually we already have for using the coastal acoustic tomography, not only for the fisheries, but also the river and tsunami as well. Okay, so for all the participants, please write down your question or comment on the chat or on the form, and we will discuss about it after the next presentation. Okay, thank you very much, Mr. Harun. So next, this is the last speaker, but the last but not least. So we are pleased to welcome Dr. Dhani Arifianto from the Institute Teknologi 10 November. And he is also one of the acoustic experts in Indonesia. And currently he's working on the development of natural Indonesian speech synthesis. So we are, please welcome to Dr. Dhani Arifianto. Time is yours.
Thank you, moderators, honorable guests, honorable people who are attending here, and ladies and gentlemen. I would like to start my presentation today in English. Hopefully, it's going to be short, and I would like to have a question and answer afterwards regarding these topics. Sorry, I think I have to share my screen first. Right. Hope it's already there. hopefully it's visible at the moment on your screen. Before I start, is it okay? I mean,
Yeah,
it's all right. Okay. First of all, before I start, I would like to acknowledge people who are working throughout this from 2011 up to date. Dr. Wirawan, Dr. Endang Wijayati, she's in the audience, and then Dr. Yuning and Mbak Niken and so on. Many students involved in this project actually. It's all started in 2011. Yes, it is true that I was graduated from Tokyo Institute of Technology. My background is in signal processing, particularly in speech. But in 2011, it's changed 180 degree, upside down, starting with something that Dr. Endang, she was a student at the time, said to me, and then it's triggered me. That's the start of this project, actually. And well, I do not want to anyway, this is actually a slide that most of our area is Indonesian area is sea. And by law, it spans from the shallow water up to the deep water. However, I think there are problems when not only in the deep water, but also in the shallow water. Hopefully it's going to be turned around. My main aim of this presentation is to attract more people to join us, to join our effort in order to know more of our country natural resources, particularly underwater. It starts in 2011, as I mentioned before, but Sukolilo is our campus located here in Surabaya. It's actually one of my students. He was from Indonesian Navy. He asked me to be his supervisor, working on sonar, but of course for military use. I would not explain you in detail rather than this project starts everything really. I will tell you why. This the officer is from submariners, is Pa Oman, and this is what we developed in that time. We developed circuitry devices. We tested in air and then in aquarium over here, and then eventually we use it on the water. It is in the military base we use, but unfortunately in that time we are very unknowledgeable in this particular area. That's why the first we gather everybody in Indonesian Navy, our resources, try to mix everything works, but ultimately this is the photos from the early days of our working that ultimately failed. We try to find out in that time. It tracks down. We try whether it is the electronics, whether it is the setting. Was it the programming? We try to crack everything down to find out which one is the probable cause that failed us in the first place. So it turns out that we forget many things. The very basic in the sound propagation in the water. It doesn't has line of sight. It's deflected with respect to speed, with respect to salinity, with respect to pressure, as well as temperature, as you were all aware of and familiar with. Of course, this is the early picture that we are struck with, and then we try to understand better what should we do. So we select across the board of the parameter. We very much interested in that time what is the main role of the salinity, because in the most of literature that we have, all the experiments are done in the northern hemisphere. I mean, they have less salinity compared to Indonesian Sea. So what is the effect of that? So we would like to isolate just one parameter, which is salinity in that time. We develop a tank, as you can see here. It's basically just a simple tank and small one to, and so we keep it small because we need to dilute the salt in order to create salt salinity that equal to Indonesian water mostly. So this is the setup, and then we compare all the setup to the literature that we can have on the literature. This is one of it. It is not comparable, of course, because in this particular paper, they use a much larger tank, but it is tank nonetheless. So the main issue here that we would like to focus on is the echo, how the sound is bouncing back from each side of the tank. That's our main purpose with respect to salinity. This is set up in the early days. It's very simple, just acoustic speaker, acoustic hydrophone, and in the time it's all borrowed from Dr. Endang's laboratory. This is all her setup that we can borrow in the short term in time. So this is what we have. It turns out our guess why our first measurement is failed is very much confirmed in this first simple experiment. This is the setup, and this is the sound that we generate: a ping, and then propeller, and then a bubble noise. I mean, bubble, air bubble diluted in the water. This is set up. First, we would like to measure the reverberation. This is very important because we would like to make sure that the tank still bouncing back all the sound that we generated inside the tank. So we compared 1, 2, 3 hydrophone. We put it hydrophone array inside the tank. So what we would like to put our attention is that not only we found that it is still bounce back in the first hydrophone and second hydrophone, but in the farthest hydrophone, the hydrophone 3 is the farthest from the source, it doesn't have any reflection of the sound anymore. It means that either the attenuation under the salinity properties of the salinity of the water, or perhaps the sound insulation submerged in the water works well. So we have two problems here. But our hypothesis in that time is that this might be the salinity problem. So we tested this hypothesis. It is very popular equation derived experimentally by Paul Ether. It's published in a book, a textbook of underwater acoustic, and it is a very popular equations. We plot that equation. This is according to Mackenzie equations, and this is our measurement. As you can see here, that the salinity itself absorbs almost a fifth of the power of the sound that generated, as well as the velocity also slightly. It is about 30% different from the prediction that Mackenzie equation predict. This suggests that all of our measurement done in Japan, for example, in Europe, in US, it doesn't work quite similarly, or it would deviate rather largely in Indonesian open sea. Not to mention that there are a lot of factors that have to be accounted for besides salinity. Remember, we only counted salinity in this particular experiment. And this is the second experiment that we would like to know the free field of our measurement. It seems that the result says that although it is a line of sight measurement, but the amplitude is rather up and down regardless with respect of the position. It is not quite, there is path that the sound traveled, it is attenuated more than the other path. So this is one conclusion that we have in the early days in 2011, 2012. This is similar results. As you can see, there's a deviation over there. And we would like to have a more, of course, in C, we cannot just have a pure tone, but rather that we have frequency, broadband, narrowbands. So we plot with Mackenzie and Medwin equations to see the deviation between our measurement in comparison with standard model. It seems that our prediction is we have to have a slightly adjustment about 5 to 10% from the result of the measurement in tank to the real measurement in sea. This is our tank in the last day. I would like to ditch it because it's no longer serve our purpose because it's too small, and it is very hard to I would like to make more measurement in the open air, open water. This is now the tank. Again, we would like to thank Dr. Wirawan and Dr. Endang Wijiati for the facility. It is impossible to run these experiments without their role. Using this facility, it is huge facility, and it is not just another swimming pool, obviously. So we can measure in more detail without any salinity, of course. Now we would like to see in terms of the width, the pressure, and the depth, because hopefully we have more depth pressure in this tank, a huge tank that BPPT has. This is the result, the comparison between mini tank in the left and the towing tank, the huge tank in the BPPT side. It seems that it's a kind of scale up result. It is still consistent with our prediction that even without salinity, the sound propagation and the attenuation is still in line with our prediction in our revised model of the Mackenzie empirical model in the first place. And this is the in terms of temperature. In the same temperature, we generate 1 kilohertz sound, and much lower than that, 200 hertz, to see where the attenuation at the most at the frequency that we generated. It seems that the more frequency that we generate in the larger the frequency, I'm sorry, more frequency, 1,000, 9,000, 8,000 hertz, the more and more attenuations. It means that if we would like to have its longer range for communication, we have to, unfortunately, we have a very restricted bandwidth with respect to the condition of the water in the towing tank. Then we would like to see another. We would like to see another things, which is backscattering. And this is our setup in the real pond. This is mud, basically. So this is a real pond, water, fresh water. There is no salinity in there, but it is much larger than our mini tank. And then the floor is not hardened, but it is rather a mud, just like, hopefully it's similar to ocean floor. We set up our experiment like this, and then we see what kind of attenuation because of the floor. This is what we have. We generate 9.2 kilo and then 8.5 kilohertz, respectively, in the left and on the right side. If you see the larger frequency that we generate, it seems that in this particular part, it's kind of shifted. I mean, the position is the same of the source, where the acoustical wave inside traveling on the water, when they collided each other, it is concentrated in this particular point. As it moves, because of the move the depth of the hydrophone, the measurement, and it shifted a little bit to the upper side in this area. When we lower the frequency, it is still there, but suddenly with the similar depth, it is no longer interference between inside the pond, which suggests that the attenuation on the fresh water with the mud floor, it is much larger compared to the salinity. We derive attenuation new. We propose a new attenuation coefficient in terms of energy absorbance inside the water, as well as the pressure, as well as the salinity. We kind of pull them all together, and then this is what we have. So as we see here that the coefficients here are much larger than the Mackenzie and Medvin equations. So now we try to apply them for object tracking submerged in the water. Is it going to be pick up the object that move along a fish or even a submarine, for example? Is it going to detect that there is an object underwater, or is it going to be undetected? So we set another setup. It seems that as the attenuation grows, as we predicted, so the performance is also degraded significantly. But with help of we applied compressed sensing, we have better results. So we can push all the way down. So keep the to push all the way up. So the performance is increasing more than twice if we applied a certain signal processing technique in order to boost the performance of the estimator, even when the measurements is incomplete because of the attenuation of the water. To sum up, we achieved so little. So there are more to come. We're still working on some keywords here: scattering, ray tracing, sparse sampling, blind spots, steerable beamforming. And again, I couldn't thank enough for Dr. Wirawan, Dr. Endang, and all of our students. And this is funded by our sponsors from Directorate of Higher Education, Indonesian Navy, and also campus local funding. In the end, I would like to ask to the audience, if you are not IEEE Ocean Engineering Society members, please join us. And it's definitely fun to work with all these people, to work on water problem. And certainly, particularly Indonesia, requires all this research in order to not only for its defense, but also for our society, for welfare, well-being, in disaster mitigation, as well as for the daily life in terms of fishing, natural resources, and so on and so forth. And this is one of small picture that I can capture is from IPB in Bogor. Is student activity as well that the Ocean Engineering Society has. I think that's all for my presentation. Thank you very much for all your kind attention, and I look forward to discussion. Return to you, Dr. Rainey. Thank you.
Okay, thank you very much, Dr. Benny. Very nice and very wonderful presentation. This is also make the idea for us. So actually for the development of coastal acoustic tomography, we still facing a problem related with the transducer because we still import from US. We try to, the next step is we try to make on our own possible. So it's also to see your presentation is very nice. So thank you very much. So now we start for the discussion. We receive many questions for the participant, and we summarize some of them. Let me share screen. Okay, so this is the first question already answered by Professor Arata Kaneko. So maybe we can move to the next question. The first one, for the case of early warning system, please explain shortly or simply how to decide whether storm surge or tsunami happen or not with respect to time to alarm. So I think this question for Professor Kaneko. And later, maybe
in my first original plan is a tsunami alarm. Tsunami alarm is done by the submarine earthquake is detected. When submarine earthquake detected by government, our tsunami cat system is change the operation method from normal mode to tsunami mode using the FTP server data connection. After submarine earthquake occur, or it's maybe the after submarine marine earthquake occur, maybe we have a 30 minutes or 1 hour, or it depends on the position of epicenter. How many hour time minutes we can understand the how many minutes we have to detect the tsunami wave. So I can answer your question, or
yes. Thank you, Sensei. So the conclusion is like we did the time to alarm based on the instrument. We change the normal mode to tsunami mode if we receive some submarine earthquake or information, something like that.
Yeah, if you put the some one text file in the your BPPT FTP server and field tsunami catch this one text file and automatically tsunami cat change the observation method from normal mode to tsunami mode. It's different is a transmit interval of sound. Generally, 10 minutes interval you use to measure the ocean current normally. And in the tsunami mode, 30-second interval, 20-second interval can be used.
Okay. Yes, thank you very much, Sensei.
Okay.
Okay. So I hope it can little bit answer the question from the participant. So next question, this is I think for the Mr. Harun, how to conduct the resolution test? How can the result can detect moving object accurately? Is there any limitation to the speed of the object? Oh, I think this is for both Kaneko Sensei related to the fish and Dr. Fadli related with the stock assessment, because the object in here is not specifically something. And later, Mr. Harun related with the submarine moving detection. So maybe the first Kaneko Sensei.
Any question is welcome. Any question is.
Yeah, so Kaneko Sensei, maybe you first. So how can the CAT system detect object for fish or for any other object? And is there any limitation to the speed?
What limitation of tsunami measurement? Limitation of tsunami measurement or?
No, Sensei. This is already related with any other object. So like submarine or fish or something that we can detect by our instrument.
Please explain again. What is your question is what not only tsunami measurement.
Yes, this is for our general CAT system. So how the CAT system conduct the resolution test, and then how can the result detect the moving object?
Moving object. Moving object is yeah.
Maybe I can add, Sensei.
Yes.
Yes, for the especially moving object, we have already the project in 2017 by Respect Funding, and we did actually detected 403. We call it. That's actually now is last month is sunk already 403 Nanggala, yeah. And at that time we can detect the signal using only just single transmitter. So we put this on the like a fishing plate, and then just put one direction, so we can get the backscatter in the signal, and then we analyze. So in terms of moving objects, there are several ideas. And in the case of the piece, because this is quite difficult related to the dimension. So I show you that our idea is to put like two transmitters along the source, and that's depend on the distance, yeah, on the distance of the object, moving object, in this case a piece. And I show you already some equations and diagrams. So we can understand that actually depend on the size of this piece. So in our calculation, like 10 or 20 centimeters of this long piece is related to the some like distance, maybe needs the 1 kilometers or something like 500 or 1,000 meters, and this related with some target strength. I mean, with related to the decibel is about 32. So maybe some others will asking us how to differentiate. This is the more critical question between the tuna, the bigger one that can reach like 1 or even 2 meters, and with the scum like a small piece, pelagic or a demersal piece, like on the corals. So this is very much depend on this kind like target strength and the dimension. So like the relationship show that say like 20 centimeters related with the 32 target strength decibel or something like that. So this is maybe for some big pieces, the target strength is become stronger. Yeah, that's the idea is like that.
Yeah, previously I considered I proposed the CAP coastal acoustic measurement to detect the offshore moving animal or moving obstacles. Yeah? So at that time is maybe the one target size is 1 or 2 meter, or maybe 1 kilometer, 2 kilometer, or it's can be detected, or the limitation of detection, the limit of this detection is 1 kilometer or something like that, or not so big. Or up to fish target strength from the fish is depend on the direction of fish. If fish is fish body parallel to the station line at the station to station direction, parallel to the station to station direction is a much target strength is much better. But fish is make a different direction. Target strength is changing very much. So this is a active detection method. CAP use the active detection. Another is passive detection is possible. Then usually the detection of submersible is used the passive method. But recently, as you know, the tsunami detection, maybe tsunami coming the tsunami cat system, tsunami located at the entrance of strait, tsunami make a friction to the coast. Some noise is generated by tsunami. So if this tsunami closing to the tsunami cat system is underwater noise is increased, and So I add the one parameter, environment sound noise. Underwater sound noise is present tsunami cat can measure the underwater sound noise. So present tsunami cat system have this ability to hear the tsunami friction noise.
Yes. Okay. Okay, Sensei. Dr. Fadli, thank you. So,
Okay.
We next question. The first question, based on studies and research, what are the results of the earthquake and tsunami mapping in Palu, Central Sulawesi? This question already answered by our expert also, Dr. Marina, in the chat room. Yeah, because we have a different topic today, so the explanation maybe later we can get by chat room. The next question to Dr. Fadli: how you can differ the pelagic stock compared to the demersal fish stock? Is there already a special technique to compare the two stocks?
I answered already on the previous
Yes.
explanation. I did already.
Yeah. Some. Do you want to add some information, or it's enough?
I think no. Just this. That's different on the actually the diameters related to the target strength only. So if we have we can specify several kind of diameters, and we understand some pieces related to the with this kind like a size, then we can identify by experience. I mean, if we did many times, then we will get actually with this kind like a size and target strength, we can understand this kind of several stock or something like that.
Okay. Thank you very much. So for the next question, did the acoustic topography use Doppler effect? If not, how can detect the moving object?
No, don't use the Doppler effect. Doppler effect is make a digital effect to the transmission sound, but this effect is very small. We don't need to consider Doppler effect so much.
Okay.
Anyway, cat don't consider the Doppler effect. It's neglected.
Okay. Thank you, Sensei.
Yes.
Yeah.
Moving effect. Moving if cap coastal moving cap is applied.
No, not moving cats, is it? Moving object like submarines. Or
Submarine. I didn't estimate the transmission signal. How transmission signal transmission signal is influenced by submarine, but it's back reflection from the submarine is so quick at the instance, and cap station is fixed at the coast. Cap station is and how massively is moving, and Doppler effect is can be calculated.
Okay.
And also, I think I add sensei, indirect detection can be used also by identifying the natural phenomenon, like for the submarines, if they make a quiet the engines, yeah, even the stop engine with the very small propellers moving, but we can still detect through the wakes of this kind like a submarine. So this is the capability of acoustic tomography actually to detect some kind of like natural phenomena. In this case, this wave we can mostly the same like internal wave, but of course with a different strength. Yeah.
You know the passive method and active method is there are active and passive method to detect the submersible and moving animal, moving obstacle.
Mm-hmm.
Which do you imagine?
No, any kind of ways. We explained already many. Yeah, we can just keep. We explained
Maybe,
already.
yeah, maybe you want to check the active method.
Yeah.
Yeah,
They just want to know. Yeah.
Do you know the marine mammal, whale
Yes.
researcher? Whale researcher is want to apply the active method to detect the very big whale. And one paper in one difference paper, 3 kilometer, 5 kilometer is was detected in this paper.
Okay, thank you very much, Sensei, for the answer and also Pak Fadli. So for the next question, maybe this is related with the activity in BPPT. So Mr. Harun can answer. Is there any experiment case by using artificial wave, which a little bit like tsunami, or success story of acoustic tomography for tsunami early warning system? Mr. Harun, please.
Okay, thank you, Dr. Reni. First, I will add the question with resolution test. In coastal acoustic tomography, there is different resolution tests than the radar data or the satellite data. The resolution test in tomography we use with pair station. If we attach the multi-pair station, the resolution will become good. And with this question, this tickets is under development because of in the end of 2020 we start just in the end of 2020. So yet there is not yet a success story because of still developed. This year we scheduled experiment using artificial wave or bone wave in Sumatra. Thank you.
You're talking about the second question.
Yeah, yes, Sensei.
Artificial wave. What is artificial wave? Artificial wave is not a sound wave.
No, Sensei, for example, in our laboratory, we have the tank for develop some wave in the laboratory scale. So experiment scale.
Artificial wave is a reverberation.
Sorry?
Reverberation. Dr. Danny-san talk about the reverberation. If sound is transmitted sound is reflected and reflected bottom or surface.
Sensei, this
Yes.
is only wave generated in the laboratory. This is only to see the similarity or something like that. Just
Yes.
for one purpose, the experimental, they try to generate like a tsunami. So they make a artificial wave like a tsunami in the laboratory. Only this. Only this.
Laboratory wave, tsunami is a gravity, surface gravity wave only.
Yeah, of course,
same as
this is difficult, Sensei. Of course, this is the question. Of course, difficult. This is only the question. So, what's Harun explained actually, they try to measure on the reality like a tidal bore. It's quite similar like a tsunami. So some tidal bores in Sumatra rivers, so they try to measure this just for the comparison. So
Okay.
like
Okay, I should explain. Tsunami wave and common surface gravity wave different is only period, except the period same. Tsunami wave and surface gravity wave same in dynamics.
yeah. Yes.
Yeah.
Period
Okay.
is different, only this.
Yeah.
Tsunami have a 10 minutes period or something.
Yeah.
A kind of wave packet. Tsunami have make a wave packet.
Okay.
So this just the question for the participant. So the answer not yet. So we are not yet making the experiment related with the tsunami early warning system that we will do in this year.
Reni-san, I have to make a comment to how tsunami chat operation and data acquisition is so difficult in Lombok Strait. Lombok Strait is the 40 kilometer width in width and so deep. So I advise without surface mixed layer, it's impossible to get the transmission data. So I watched the Hakuomal 2019 data. All 3 points have a surface mixed layer. So I don't know, along the transmission line, all points have a mixed layer, ocean surface mixed layer, constant temperature layer. If it exists, sound transmission is so easy, even for the 40 kilometer. So if I want to verify this, but at that time, please you tell your team, including the Harun-san, multi-repeat transmission, multi-period transmission is needed. Because if we use the multi-period transmission, received data is amplified to signal to noise ratio of received signal is amplified by the summation of the multi-period data. It's a little bit advanced part. Your team don't understand this. We prepare this multi-period. Our system have an ability to do this.
Yes. Okay, I think it's already more too technical, Sensei. So because we have time also limited, we still have the question. So for there is two questions. One, are there plans to mass production this tomography device, or what test are still needed? I think in here I can answer on behalf of BPPT. So we try to make the river tomography by ourselves, but we until now we not yet plan to make the mass production. And
if you have a question is on the display or it's written is much better.
yes, Sensei. So because this is in the chat room. So another question is for Dr. Denny. Are there plans to mass product? Sorry. Oh, sorry. That's the question for Dr. Denny.
Yeah.
Are there plans to mass production this tomography device, or what tests are still needed?
Your question is don't appear in the display or?
Yeah. Oh, wait a minute. This question is for Dr. Denny Sensei.
申し訳ございません、先生。答えていただけませんか？
Please give me the question.
Yeah, so please, Dr. Denny, to answer this question.
Right. Well, my project is basically for Indonesian Navy. So yes, in the end of the day, we would like to do this because I cannot describe more because it's kind of a classified project that we're working on because the nature of the funding, and in the end of the day, I think this device is going to be placed in Indonesian waters with regards to safety. But however, since the nature of this talk today is of the welfare, I think this kind of technique that we use in this particular setup is actually can be modified slightly for commercial or civil applications with no trouble at all. But if it is mass production in terms of commercial, I'm afraid that I cannot do that because at the moment we have a contract for the Navy, and I think you have to talk to the top brass in the Navy headquarters for this. I think Dr. Endang is going to have a different opinion about this. Hopefully, if it is okay, we can switch this project to commercial mass production.
Please,
yes, of course, yes.
Please explain the mass production a little bit more. What is the mass production? Is
you can call commercial devices that anybody or any government body can use or place the device.
Mass production in the ocean, mass production, what fish or what is mass?
No, so this is related with the like fossil. We sell in the market or something like that.
Mass. Sorry, market production.
Market production, yes. Showing this.
This is the most important, difficult and important point. Or Goda Sensei design. Chat is designed by Goda Sensei, Dr. Goda, and he. But Baryu Sejo-san can construct the chat now. Why Baryu-san cannot make a mass production?
Yeah.
Why?
Yes,
What's the reason?
Me?
Baryu-san can do.
Sensei, this is not only related with the coastal acoustic tomography, but the device that Dr. Denny already making, or product of Dr. Denny. So this is not our instrument, Sensei. Different instrument.
What the instrument? Dr. Danny-san talking about.
Danny Tomoshimasu.
What the instrument?
Basically, what we developed is similar to CAT actually, but instead of the measurement of the movement of the water, what we measure is the displacement of the, if something was submerged on the water. So we can track how big it is, the shape of the object, and then the speed, and so on and so forth. It's similar to radar actually. So what we have is our device at the moment is somewhat similar in terms of how it works with cats, but in terms of how it arranged, it's a little bit different. So well, it's kind of similar to radar actually, where we would like to detect an airplane. I'm sorry, I cannot disclose further because it's
your question point is very interesting, but everybody wants to make such a question. But in my policy is quite different. I have interest in the only acoustic tomography, because this is nothing in the world, and the role of the cat is very wide. Everybody in the who do the coastal sea work or sea working is important for everybody, but it's not don't exist in the world market. So we have to stop. We cannot stop. If it's important, but I don't know why such an important instrument is not well operated in the world. It depends on the US policy. US tomographer have interest in only deep sea, and he is they are all except for the great professor Walter, all researcher is ocean acoustician. I am not ocean acoustician. I'm a physical oceanography, ocean fluid dynamics, quite different from the ocean acoustic. So I am just a user of CAT. I asked the Professor Goda, Dr. Goda to design and construct. And I asked many things for user friendly. If CAT system is suddenly stopped in the field. So I asked the Dr. Goda to add the PIC microcomputer. PIC microcomputer is small, but watch the CAT operation. If CAT is down, this is frequently occurred in the TCAT. Okay, TCAT. So I asked the Denny-san to do a little bit more. TCAT is suddenly stopped, but PIC microcomputer wake up the system and operation continue. But this is sudden.
Sorry, Professor Kaneko Sensei.
はい、わかりました。
わかりました。
どうもありがとうございます。
That's important. So I have to stop. I cannot stop the service.
So this is very interesting discussion. So I think maybe we can make the second part or something, part B.
Yes,
for this discussion.
it's easy to using the Zoom. It's easy every time.
Yes.
No problem. I'm
So-
free, not so busy. I'm not so busy after retirement.
So once again, thank you very much for Professor Arata Kaneko,
Yes,
Dr.
welcome.
Fadil Samsudi, Dr. Dani Arifianto, and Mr. Harun Idam Akbar for the speaker today. We are really sorry if there is still some discussion or question. Maybe later we can have more technical process or something. So today this is like introduction to what is the capability or application for the coastal acoustic tomography, which BPPT developed during this recent year. So once again, thank you very much for the discussion and also for the question, comment from all the participants. I would like to close for this session with some small sentence. So innovation of the coastal acoustic tomography now in Indonesia still in the middle stage level, and we can all collaborate and join for the further development. So we are welcome for all of your collaboration, actually. Thank you very much for your time, and I am giving back to Mbak Zilda, and see you again for the next opportunity.
Okay, thank you very much, Dr. Reni. Giving a big applause to Dr. Reni and also for our distinguished speakers. And it's like Dr. Reni said that it's really interesting topic with a tough discussion also, I think. And as we bring our coastal acoustic tomography to a close, we once again want to say thank you to our speakers, our moderator also, and hope that this activity has given us to a clear understanding about the coastal acoustic tomography for the welfare of coastal communities. But before I close this webinar, I would like to invite Dr. Agustan to give some speech and also give some appreciation to our speakers. Please, Dr. Agustan.
Okay, thank you, our master ceremony today, our fabulous Zilda. Thank you, Zilda, for this afternoon session webinar. So on behalf of Center of Natural Resources, Regional Resources Development, or PT PSW, I would like to thank to all the speakers, Kaneko Sensei, Pak Fadli, Pak Harun, Pak Dani, and also to moderator Ibu Reni. Thank you very much for sharing the knowledge about coastal acoustic tomography. So this is quite new for us. So maybe we're still blank here to understand the theory and the application, but looking at the picture that's set by Pak Harun is very interesting to us. So, and also the picture from Pak Fadli. Yeah? So now we understand what is the coastal acoustic tomography and how complexity it is by Pak Dani. So I hope all the young scientists, younger researchers maybe can interest to assess this new technology and join for the many club or research group related to the coastal acoustic tomography for marine resources. So can we share our appreciation to the presenter? So we would like to awarded the certificate to Pak Fadli. Thank you very much.
Thank you, thank you.
Yeah, and then also to next speaker, Pak Arata Kaneko Sensei. So thank you very much for your time for us.
Excited, so excited.
But I'm sorry, bahasa Indonesia Sensei, not in Japanese. So maybe Zilda must come to Japan to learn kanji to write the certificate properly. Zilda, next time you must write the certificate in Japanese, yeah.
Oh, okay, okay.
Oh, Japanese.
Yeah, so you must go to Japan.
Yeah,
give the
thank
short
you.
course.
Very nice. Huh?
Yes, thank you very much. And also the next speaker
Nice.
to Pak Dani Arifanto. Thank you very much.
Oh, arigato, arigato,
To you.
arigato.
Thank you very much. And also, what next, Silda?
The last one is Mr. Harun.
The last one is for Harun Idam Akbar, our young generation for this technology. So hopefully it become continue your research In Japanese we say gambarimasu to understand
Gambatte kudasai.
Gambaro.
tomography.
Gambaro.
Gambaro. Gambatte kudasai ne Harun. Harun-san, Harun-kun.
Harun-san, youngest だから頑張って。
Yes. Okay, thank you very much on behalf of PTPSA. Thank you very much for all the audience. And all the certificate also will be provided by Pak Robi and Bu Zilda through the chat room. So thank you very much. So I return back to Zilda.
Bye bye.
Okay, thank you very much, Dr. Agustan. After Dr. Agustan giving the certificate to all our speakers, so this is will be our end. On behalf of our unit, Center for Regional Resources Development of Technology, and our speakers, and thank you for this evening session, and see you next time. Goodbye. Thank you, everyone.
Thank you. Good, nice chair. Thank you very much. Terima kasih.
本当にどうもありがとうございました、先生。
Arigatou gozaimasu.
Sugoi nih.
Terima kasih.
Terima kasih.
Terima kasih.
Terima kasih
Terima kasih
semua.
Bu Endang, terima kasih semuanya. Terima kasih Pak
Terima
Agustan, Bu
Mudah-mudahan-
Eni.
Mudah-mudahan
kenal,
kapan-kapan
siap.
bisa ketemu darat ya setelah selesai semua pandemi ini.
Ya.
Ya, kalau dipanggil sama Bu Endang kita siap ke
Loh.
Surabaya.
Ya.
Kita siap
Pak
menghadap.
Fadli masih ada di sini. Pak Fadli juga udah pernah ketemu Pak Dani sebenarnya. Cuman saya nggak tahu Pak Fadli masih ingat apa enggak.
Pak Fadli sejak minum
Oh,
air
gitu.
laut
Tadi
di
Pak Fadli-
Sulawesi Barat udah mulai agak lupa-lupa ini ingatan.
Mungkin Mas Robi bisa hentikan live Zoom-nya dulu.